ADLINK ensures that all our products deliver flawless performance for the length of their life cycles. This is a cornerstone of ADLINK's robust, reliable, and ready quality commitment to delivering industrial standard systems and platforms. While specific performance requirements vary with the many environments in which products are applied, in-depth validation and verification is an integral part of the R&D process for all our products. To ensure their effective application, ADLINK established its 5 labs, dedicated to providing the platforms and expertise necessary to ensure full-scale functionality and reliability. First is the High-Speed Simulation Lab, featuring everything necessary to perform pre- and post-layout electromagnetics and circuit simulation testing. Virtual prototyping provides highly accurate predictive pass and fail reports for high-speed signals and more, while signal integrity simulation assures timing and noise margin specifications for all PCB interfaces. Precisely timed simulations guarantee PCB design flow is uninterrupted by board spins and rework. A typical process flow includes pre-layout and post-layout simulations, the results of which support establishment of layout rules for PCB compliance necessary specifications. The simulation reveals signal bus limitations in the design and informs their rectification. Post-layout simulations access actual board topology and routing to verify proper efficient interface function adhering to the original design. Further, troubleshooting based on post-layout simulation identifies possible root causes of these and other issues. The High-Speed Signal Verification Lab, receiving new hardware ready for testing, is equipped with numerous high-end signal analyzers and oscilloscopes. Interfaces of the boards under test are measured and tested against expected specification using specific probe attachments, test procedures, and patterns. The lab has the capability to conduct electrical verification and compliance testing and logo certification for a number of technologies, including HDMI 1.4b, USB 3.1, DisplayPort 1.2a, SATA 6 gigabits per second, and 3rd generation PCI Express, and is further equipped to test the integrity of power supplies under different simulated load and transient conditions. Also accommodated is independent testing covering internal signal measurement and multiple high-speed connectivity standards, including system clock, SPI and I2C interface, DVI, LVDS, SATA and 3rd generation PCI Express using high-speed differential signals via the DRAM interface for DDR3 and DDR4. Networking interfaces ranging from IEEE 802.3, Ethernet with speeds of 10, 100 megabit and 1 to 100 gigabit utilize Ethernet, base CX, KR, KX, and SFP, SFP Plus, and CFP interface standards. Anticipating the demands of high-speed Ethernet, IEEE 802.3BA with 40/100G. For the telecommunications industry, we have prepared all necessary testing solutions to ensure correct design implementation for the most demanding interfaces. In the environmental lab, tests performed include dynamic testing, which includes measuring tolerance to mechanical shock at accelerations of 20G to 200G at 2 to 11 milliseconds, and vibration testing with frequencies from 5 Hz to 2000 Hz with 0 to 10G acceleration, ensuring the products can meet specifications such as MIL standard 810G. Packaged products undergo drop testing to ensure the rigors of handling and shipment do no harm. Climate testing is performed during the early sample stages, as well as burn-in and extended temperature testing. The lab features 30 climate chambers capable of producing temperatures in ranges including from -60 degrees Celsius to 150 degrees Celsius with controlled humidity. Devices under test undergo temperature profiles with several temperature dwell points and device test cycles, during which temperatures, voltages, and outputs of the device under test are constantly measured and recorded. The data is logged online and can be verified by the design engineer at any time to identify anomalies and potential issues in the tested device. Special test chambers also perform HOS halt testing, accelerated stress tests enabling identification and elimination of problem points in design. Electrical testing includes power input tests with over-under voltage, noise, spikes, and brownout conditions. ESD protection testing verifies system and interface ability to withstand applied voltage levels, while in-house EMI/EMC pre-testing ensures component and system compliance with emission limits, such as those established by FCC Class A or B. The mechanical lab, during thermal design, simulates predicted temperatures and airflow on the boards and systems. A special wind tunnel verifies thermal resistance and resulting temperatures of the DUT to guarantee compliance with the specific specifications. Also measured is flow resistance to ensure sufficient cooling capability, allowing optimal sizing for system fans to maximize noise control. Many systems require specific ingress or IP ratings to prevent dust and water ingress. This standard is verified by application of negative pressure up to 50 kPa for ratings of IP65, IP67, and IP68. PCB warping, a result of the SMT process, is measured by precision table and instrumentation to verify that warping is within allowed tolerance. Stress from pressure on a chip must be evenly distributed over all solder balls, and strain gauges on the board verify that variations are within allowable tolerance. Since highly integrated processor chips can only tolerate a limited amount of force, usually from heat sinks, the force applied by each heatsink is also measured and ensured to be within specification. Capacitive touchscreens undergo special testing for linearity to guarantee accurate response over the entire area. As well, switches and connectors undergo rigorous lifetime function testing using automated equipment. In the RF lab, function and signal quality of critical wireless communication interfaces are verified. The lab itself is a shielded environment, insulated up to 100 decibels from 100 kHz to 18 GHz against electromagnetic signals and interference. Measurement verifies 3G LTE, Wi-Fi, NFC, and Bluetooth functionality via instrumentation including a variety of RF spectrum analyzers and specialized function testers for conductivity and radiation testing. ADLINK's 5 labs guarantee the performance, dependability, and functionality of every ADLINK product from start to finish. ADLINK